Good morning, children. It's Sanjeev Pal from Srimati LPSAVANI VIDHYABHAVAN, your statistic educator, welcoming you all to the class of statistics. Here, children, we shall see our example number 16. We need to find out the standard deviation and the coefficient of standard deviation with the help of the shortcut method. Right? Here is your example number 16. What they are given: the information of the number of mobile phones sold in last 35 days in a mobile shop is given. Find the coefficient of standard deviation of the number of mobile phones sold. And over here they have told us to use the shortcut method. You would find over here number of mobile phones sold has been given to you, and just another row that you will find is the number of days. Okay, that's 2, 5, 8, 12, 7 and 1. So it shows that for how many days, how many number of mobile phones were being sold. So number of days is your frequency, and what is your number of mobile phones? It is the column of xi, right? So over here you would find that we have the column of xi, that is 5, 6, 7, 8, 9 and 10. We are having the column of frequency, that is number of days, that is 2, 5, 8, 12, 7 and 1. Now, to find out the standard deviation, children, as per the formula, okay, we know if we are using the shortcut method, right? While we talk about the formula, now before that, I just want to discuss one thing. Now, see, children, over here, while we talk about the deviation, see the deviation over here. Your deviation is x minus a. That is x minus assumed mean. Okay, over here we have not done that x minus a upon c. Okay, we have not done upon c, or you can say in the deviation we have not changed the scale has not been changed. So when the scale has not been changed, right, while we talk about say the shortcut method, the formula for your mean becomes what? The formula for your mean in the shortcut method becomes a plus sigma fidi upon n. You will not multiply this formula by c. Okay, why we will not multiply this formula by c? Because the scale has not been changed into the deviation. That's why the mean by the shortcut method becomes a plus sigma fidi upon n. And what is your a? A is your assumed mean, right? Similarly, while we talk about, say, the formula for the standard deviation, we are not going to multiply the formula by c. Why? Again, the same concept, that we have not changed the scale as we found out the deviation, right? So over here our next column, okay, is of first of all we'll just find out the assumed mean over here. And I have told you many times that assumed mean, okay, should be any number from the middle, right? But in the middle you would find that you are having, see the column of xi, you are having 7 also and 8 also. Okay, so which number to be taken as assumed mean? You will always find that the highest frequency out of the two, the xi which is having highest frequency out of the two, okay, will become your assumed mean. Over here you would find, while we talk over here, the frequency for 7 is 8 and the frequency for 8 is 12, right? So the highest frequency is 12 out of the two, and against it the value of xi is 8, and that's why what is our assumed mean? Our assumed mean is 8. Now for the deviation, as I told you, we have not changed the scale, only the origin has been changed, that is x minus a. Okay, so what we need to do now? We need to just do xi minus a for the deviation. Okay, a is our assumed mean, that is 8. So your 5 minus 8 will give you minus 3, 6 minus 8 will give you minus 2, 7 minus 8 will give you minus 1, 8 minus 8 obviously 0, 9 minus 8 is 1, and 10 minus 8 is 7. That is how you say found out the deviation, right? Now comes what? Now comes the column of fidi. So while we talk about fidi, okay, what we need to do? We need to just multiply fi and di. So 2 3s are 6, plus minus minus, 5 2s are 10, right? Plus minus minus again, your 8 ones are 8, plus minus minus, 12 zeros are 0, then 7 ones are 7, and 1 twos are 2. You will again do the total of this. You will get something like FIDI minus 15, right? Why we found out FIDI? Because we needed it in the formula of mean, and the same is needed in the formula of a standard deviation, right? Now for the formula of standard deviation, what we need FIDI square. We need FIDI square, the column of FIDI square. And for the column of FIDI square, what we need to do? We need to multiply the column of DI and FIDI. So over here, you would find your 3 6s are 18, minus minus plus, right? 2 10s are 20, minus minus plus, 1 8s are 8, minus minus plus, 0 into 0, 0, 1 7s are 7, and 2 2s are 4. Again, you will do the total of it. You are getting 57. Right. So that is your FIDI square. Now we have found out all the columns. Now we can basically find out the mean, standard deviation, and the coefficient of standard deviation. Firstly, over here we will find out our say mean. We are going to find out mean first of all over here, right? So over here, while we talk about mean, and as we had discussed, it is A plus sigma FIDI upon n. Your assumed mean was 8. So 8 plus FIDI, sigma FIDI, we have seen it was minus 15, divided by your n is actually 35. So divide by 35. Again, as I tell you always, just you solve the right hand side first. Okay, it will come something like it's coming minus 0.4286, right? Just you will do the deduction. You will get your mean is what? Up to 2 decimal places, 7.57, and your xi was your number of mobile phones. That's what the unit would be. So 7.57 mobile phones. That is you can say approximately 8 mobile phones. So that is actually your mean. Now we are going to find out the standard deviation and say coefficient of standard deviation. Okay, here is the standard deviation now, right? And this is the formula of standard deviation, as we had discussed the formula of the standard deviation. As I told you that you are not going to multiply it by C. Why not going to multiply the formula by C? Because the scale has not been changed into the deviation, right? So that's what is the formula in the shortcut method, that your S is equal to under root sigma FIDI square upon n minus into bracket sigma FIDI upon n whole square. Right now, from the table that we basically saw in the last page, you find all the values. You're going to put it up over here. You're going to use the board mass, right? And you're going to solve it out, right? So 57 divided by 35 will give you 1.6286 minus you are going to do minus 15 divided by 35, and you are going to do the square of it. It's 0.1837. Okay, you will deduct both of them. You're getting under root 1.4449, right? And just doing the under root of it, you will get 1.2020. That is approximately 1.20 say mobile phones. Okay, but now in the sum they told us to find out the coefficient of standard deviation, right? We found out the mean. We found out the coefficient of found out the standard deviation also. Now the coefficient of standard deviation. Now coefficient of standard deviation, we know the formula that it is always our S, that standard deviation divided by mean. S we just found out above, that's 1.20 divided by mean. Just lastly, just we found out the mean, that is 7.57. You will just divide them and you will get the answer is 0.1585, and if we write up to 2 decimal places, it would be 0.16. And as we know, we don't get the unit of a coefficient of a standard deviation. It is actually, so the final answer would be 0.16, right? Because we don't write only the unit for coefficient of standard deviation. Now here we shall discuss the 18th sum. Now I have not taken the 17th sum, because after doing the 18th sum, you would be able to do the 18th sums, right? But in our online classes, we have already discussed the 17th sum, right? So just right now we'll get on with our 18th one, right? See what they given. Find the standard deviation of the daily wages from the following information of the wages in rupees of the workers of a factory. Over here, daily wages in rupees has been given to you, right, and number of persons have been given to you. Okay, it has been given more than 130, more than 150, more than 170, more than 190, more than 210, and more than 230, right. Now over here it is more than type of cumulative frequency distribution have been given to you. Okay, even number of persons has been given to you, but the more than type of cumulative frequency distribution has to be converted into, say, the normal continuous frequency distribution. Over here, one thing you will notice, if you see the row of daily wages, it's more than 130, more than 150, more than 170, more than 190, 210, and 230. You will find the differences between the numbers, okay, is of 20. So we can say it is our say regular type of frequency, continuous frequency distribution, or you can say the class length is the same for each and every class. So below it you would find the table which has been given to you, or you can say those two rows which have been given to you of daily wages and number of persons. They have converted into, say, the normal continuous frequency distribution, because over there above you will find more than above you would find more than 130 is been given, right, and as the class length is of 20, okay, the first class which has been taken is 130 to 150. Similarly, more than 150 is there and class length is of 20, that's why it is 150 to 170, right. And how it actually goes on, that is the next class, okay, you would find is 170 to 190, then 190 to 210, and then 210 to 230, right. Now how we are going to find out the frequency for the same, right. The frequency, okay, you would find it's 150 minus 142 will give you 8. Then this 142 minus 116 will give you 26. Then this 116, right, say your minus your 57, okay, you would find will give you 59, right. So that is how the frequencies, okay, you are going to find, okay, and the frequency you would find is actually 8, 26, 59, say 43 and 14, okay, in the same manner, right. So this is your regular continuous frequency, say, distribution, right. Now for the so over here you would find now, okay, if you see to the table, right, you would find the classes are, say, the first one is 130 to 150, then 150 to 170, then 170 to 190, 190 to 210, and 210 to 230, right. Simultaneously you would find the frequencies, that is your the first one, okay, you would find is actually 8, right. The first one is 8, so over here it is 8, then 26, then it is 5959, then you would find it's 43 over here, and then comes the 14, okay, and as you will again do the total of the frequency, it's coming up to 150, right. Now as we need to find out the deviation also, right, we need to have the column of xi, that is mid value. Now how we are going to have the column of xi, you now know very well, right, how to find out the mid value. That is for the first class, okay, you would find 130 plus 150, that is 280 divided by 2. 280 divided by 2 will give you 140. Then 150 plus 170 divided by 2 will give you 160. 170 plus 190 divided by 2 will give you 180. 190 plus 210 divided by 2 will give you 200. 210 plus 230 divided by 2 will give you 220. That's how you find out the mid value, right. Now the time comes to find out our deviation. Now one interesting fact you would find over here, as I told you, children, see the deviation now. Now for the deviation, what they have taken, they have also, along with changing the origin, they have also changed the scale, right. So this C, or the class length, will affect our formula also, right. Okay, now first of all, for assumed mean, again from the xi we are going to take the middle value, right. So the middle value is 180. So what is your A? A is your 180, and what is your class length? The class length is of 20. So now for each and every row you are going to actually give the effect of this formula, that is D is equal to xi minus A into divided by C, right? So you will get the values -2, -1, 0, 1 and 2 for as deviation for each and every class, right? Then comes our the column of FIDI, the column of FIDI, right? So how we are going to have the column of FIDI? Those FI 8 2s are 16 plus minus minus, 26 1s are 26 plus minus minus again, 59 into 0 will give you 0, 43 1s are 43, and you would find 14 2s are 28. Again you will do the total of FIDI, right? You are having over here 29, right? Over here you are having 29, right? So that is how you are going to have the column of FIDI, right? Now FIDI square. Now for FIDI square, we know very well that we need to multiply the column of DI and FIDI, right? So we are going to have the same 2 16s are 32 minus minus plus 1 into 26 26 minus minus plus 0 into 0 is 0, 1 into 43 is 43, 2 into 28 will get 56. Again we will have the total of it. FIDI square is 157, right? So you had your FIDI square. Now this FIDI, right, FIDI square, we are going to apply it into the formula for standard deviation. Now this is how we are going to find out the standard deviation, okay, for the same, right? Now see children, over here you would find that we have multiplied in the formula of standard deviation, we have also put up C, right? That we have multiplied this root by C. Why? Because we have changed the scale, okay, as we found out the deviation, okay, into our table, right? So now from the table, first of all, let us see the formula. What is the formula? That is, it is under root sigma FIDI square upon n minus into bracket sigma FIDI upon n whole square into C, right? Now from the table, okay, the values that we found out, you are going to put up all the values over here, multiplying it by 20, which is the class length, right? You will divide 157 by 150, you will get 1.0467 minus in between 29 divided by 150 whole square, right? That is 0.1933 whole square multiplied by 20. Then over here it is 1.0467 minus, as you will do the square of it, you will find 0.0374, right? दोनों को minus करोगे, you will get something 1.0093, right? You will do the root of it first, then you are going to multiply it by 20. You will get something like 20.0928. And what is the 20.0? You will write up to 2 decimal places. So your standard deviation will be approximately 20.09 rupees. As say the daily wages were being given in rupees. Alright. So your standard deviation is 20.97 rupees over here. Okay. Now here we shall discuss the coefficient of variation. Now while we talk about basically coefficient of variation, now as you want to compare, okay, two different sets or data is given, right? At that time we can basically do the comparison with the help of coefficient of variation. So where we use the coefficient of variation, when two sets of data are been given and comparison is to be made, and there is to be some conclusion out of it. Over there we use the coefficient of variation. Now as we talk about the formula to find out the coefficient of variation, the coefficient of variation you would find it is standard deviation divided by mean into 100. It is standard deviation divided by mean into 100, and as you are multiplying over here the formula by 100, you would find the coefficient of variation will always be in percentage. The coefficient of variation will always there be in percentage. Now just a few things, okay, to discuss about coefficient of variation. All right, just mark my words. Over here, as I told you, that it is used for basically comparison of two sets of data. So over here you would find that out of the two different datas, right, as you find out the coefficient of variation for the two, you would find if the coefficient of variation, if the percentage is more, right, we can say that it is actually less stable. If the percentage is more, it is less stable. If the percentage is less, we can say it is more stable, right? That the group or the set of the data is more stable. Similarly, if the percentage is more, we can say dispersion is more. We can say variation is more. And if the percentage is less, we can say dispersion is less and the variation is less. Similarly, while we talk about consistency, you would find if the coefficient of variation is less, the data is more consistent. If the coefficient of variation is less, the data is more consistent. And if the coefficient of variation is more, we can say that the data is less consistent, or you can say the consistency is less. Okay, as we have discussed the formula for coefficient of variation, we had seen that we need to find out the standard deviation and also the mean, right? So from the given data, we need to find out the standard deviation and also the mean. So we are going to see our example number 19, right? Example number 19. What they given in example number 19, that from the following data of the runs scored by two batsmen A and B, okay, in last 10 innings, they have told us decide who is more consistent. Now see, okay, what is the question over here? They have told us decide who is more consistent. Now, as we have discussed that how we can say that the set, or you can say the batsman is more consistent if the coefficient of variation is less, okay, or the set which will have the coefficient of variation less, we can say that that particular batsman is more consistent, right? Okay, so what has been given over here? Over here you would find into the sum they have given runs scored by batsman A and runs scored by batsman B. So that will be your xi. So see over here there are two types of data, that is batsman A and batsman B, right? And say to find out the standard deviation, right, and mean, okay, all these columns are needed. All these things we have already discussed previously into the sums, right? So that is how they have given us, right? This is the whole xi of A. So they have mentioned over here xi of A, that is you can say 25, 50, then 45, 30, 70, 42, 36, 48, 34 and 60, and as you will do the total of it, the total is coming up to 440, right? Similarly for batsman B also, right? Batsman B had scored in the last 10 innings, okay, what the batsman B had scored, okay, you would find it is actually this whole data is there, that is 10, 70, 50, 20, 95, 55, 42, 60, 48 and 80, and as you will do the total of it, the total runs scored into say the 53 matches, okay, or innings, you can say it is 530, right? For the standard deviation we know it is our xi minus x bar, right? We need to have, and we need to have xi minus x bar, and then for the standard deviation it is xi minus x bar whole square. Now as we talk about say the mean, how we are going to find out the mean? Okay, that is the old basic formula, sigma xi upon n. Over here your n is 10, right? So while I talk about our first batsman, while we talk about say the mean is going to be equal to sigma xi 1 upon n1, if I say this will be your 440, right? Your 440 divided by 10, that will give you 44, right? So that is the mean, right? That is the mean, okay, for the batsman say A, right? Similarly we are going to have for batsman B. For batsman B again is going to be equal to, while we talk about say mean or x bar 2, that is your sigma xi2 upon your n2, okay. So while we talk about xi2, the total has come up to say 530, as you divide by 10, it will give you 53. So while we talk about say the mean for batsman 2, it is 53, right? So over here you got your mean. We need to have xi minus x bar, right? So as I told you, the next column would be your xi minus x bar for both, and then xi minus x bar whole square for both to find out the standard deviation, right? Now I will be showing the calculation for only batsman A. The calculation for batsman B will be the same, right? So see the calculation of batsman A, right? I will just zoom it for you, right? So over here you would find, say while we talk about just a minute, When we talk about say xi minus x bar we have seen it is 44. So 25 minus 44 will give you minus 19. 50 minus 44 is 6. 45 minus 44, that is 1. 30 minus 44 minus 14. 70 minus 44, 26. 42 minus 44 is minus 2, and this is how you are going to do the same for the rest of the numbers. Similarly, as you do the square of it, what will happen? Minus 19 whole square will give you 361. 6 6 are 36, 1 1s are 1, minus 14 square is 196, the square of 26 is 676, the square of minus 2 is 4, the square of minus 8 is 64, 4 4s are 16, 10 10s are 100, 16 16s are 256, minus 10 would be plus 100 if you do the square of it, and then you are going to do the total of it, right? You are going to do the total of it. The total of it is coming up to 1710, right? The same thing, okay, you are going to practice, okay, for batsman B also, right? And you will get that the total of xi minus x bar whole square is coming up to 5928, right? And this two, okay, say values we are going to use to find out the standard deviation for say both the batsmen. So now here we are going to see how to find out the standard deviation, right? And then how we are going to basically find out the coefficient of variation. Okay, now we have seen that how to find out the mean. We have already found out the mean for both the datas, right? And we found the column for xi minus x bar whole square. Now over here, standard deviation, okay, for batsman A, right? Now while we talk about the standard deviation, okay, for batsman A, okay, you would find we have seen the formula already, that is it is under root sigma xi minus x bar whole square upon n. We have seen for batsman A it was 1710 divided by the number of innings the batsman played was 10, that's why n is 10. You will divide it, it will be under root 171. As you will do the root of it, right, writing up to 2 decimal places, you will get 13.08 runs, and that is your standard deviation, right? But to do the comparison, we need coefficient of variation. We have seen the formula for the coefficient of variation is standard deviation divided by mean into 100. We will take the values from above, that is standard deviation 13.08 divided by your mean is 44 into 100, and as you will solve it, it is 29.7272 percentage, and you're writing up to 2 decimal places, it is 29.72 percentage, right? Again, say for the batsman B, you're going to use the same method, you're going to practice the same method, and as you will practice the same, you would find the coefficient of standard deviation has come up to 45.94 percentage. It is 45.94 percentage. You found out the standard deviation over here, you have used the coefficient of variation over here, the formula, you'll put up all the values, and the answer that you got is 45.94 percentage. Now the time comes to compare them. As we have seen that while comparing, okay, the A and B, right, into the question, okay, they had asked into the question they had asked, decide that who is more consistent. Now as I told you, okay, that the batsman with lower coefficient of variation, okay, would be more consistent. So over here, batsman A, you would find the coefficient of variation is 29.73, and coefficient of variation for batsman B is 45.94. Seeing to both of them, you would find batsman A is having say lower coefficient of variation, and as it is lower coefficient of variation, right, we can say that the batsman A is more consistent, right? We can say that batsman A is say more consistent, right? So that is how you do the comparison with the help of coefficient of variation. Here we shall see now our example number 21, right? Example number 20 is based on this. So after doing example number 21, very nicely you would be even complete example number 20 by yourself, right? Okay, what they're given: the means and the standard deviation of heights and weights of 50 students of a class is as follows. Children, over here the table is given where they have given the mean weight and mean height of 50 number of students and standard deviation of weight and height of 50 number of students, right? So the last line, what they given, where do you find more variation, okay, where is the more variation, and among heights or weights. So when we are finding more variation, whether it is among the heights of the students or whether it is into the weights of the students, that we need to show. So again, we need to find out what coefficient of variation, and you would find over here everything is given to us, right? First of all, we'll just do the calculation for the weight coefficient of variation, right? Now as we will do the calculation of weight, again the formula remains the same. This has already been given us into the sum. Coefficient of variation s minus s divided by mean into 100. S is 4.8, that is standard deviation, divided by your mean is 56.2 into 100. Okay, it will give you something like 8.54 percentage. 8.54 percentage. Similarly, this was the weight. Similarly, we are going to find it for the height. Right, for the height also they have basically already given us the values. Coefficient of variation, say a standard deviation divided by mean into 100. Standard deviation given is 9.3, divided by your mean is 62.5 into 100, you got 14.88 percentage. Right, now into the question what they had given. Okay, we have seen they have talked about, say, the more variation, whether it is into the among the heights or the widths. Okay, more variation, that is, you can say that more percentage of coefficient of variation, so the variation will be more. Less percentage of the coefficient of variation, the variation would be less. Over here they are talking about, say, the more variation. Over here the percentage of coefficient of variation is more in height in comparison to weight, that is 14.88 percentage, okay, with comparison to 8.54 percentage respectively. Right, so as the coefficient of variation is more in height in comparison to weight, we can say that more variation could be seen into the heights of those 50 students, okay, in comparison to their weights. Right. Okay, now here we shall have the advantages and the disadvantages of standard deviation. We have seen the standard deviation, we have seen the coefficient of variation also, right? And over here we are going to see the advantages and disadvantages of standard deviation, right? Firstly, we are going to see what are the advantages of a standard deviation, right? So we'll see to the first one. Okay, the first one is being given. Its definition is very much clear and precise. Yes, children, we have seen, as you focus and observe the basic formula of standard deviation, you would find that its a definition, the way it has been given, it's very much clear that you need to find out the root of the average of the summation of the square of the dispersion from the mean. That is actually what is the standard deviation is. And so its definition is very much clear and it is very precisely given, so that becomes one of the advantages. The second one, you would find that all the observations are used in its computation. Yes, children, as in the formula of the standard deviation we also have the mean, and we know that in mean we use all the observation, so indirectly we are using all the observation in the computation of standard deviation, and that becomes one of its advantages. Right, see the third one, what they're given in the third one, that the standard deviation is the most efficient measure of dispersion among all the measures of dispersion. Yes, children, you would find while we talk about, say, the all the measures of dispersion, standard deviation is the best one, and you would find it is more efficient, and standard deviation you would find in your further studies also it is being used, so that's why it is more efficient than all the measures of dispersion. Right, similarly, see the fourth one, the fourth advantage, that the standard deviation is a suitable measure for algebraic calculations. For example, that if the mean and the standard deviation, okay, of two data are given, so the combined say standard deviation of a new set formed, okay, by combining the observations of the two given data sets can be obtained. It is not possible to obtain a combined measure in case of the other measures of dispersion by such an algebraic manipulation. Yes, children. Now, what is the fourth advantage? We will see as we will do the combined standard deviation also. Say, as you have the mean, as you have the standard deviation, we can very easily find out the combined standard deviation. Right, now it is only possible in this measure only. In other measures of dispersion you can't find out any kind of combination such. Right, so over here that becomes one of the advantages, that you are able to, if two different sets of data are being given and if you are having the standard deviation for the same, you can very easily find out one set, that is the combined standard deviation you can find, and that becomes one of its advantages, right? See to the fifth advantage, that standard deviation is the most widely used measure of dispersion among all the measures of dispersion. Yes, children. Now, whatever the measures of dispersions are, right, out of them you would find standard deviation is most widely used. Okay, more standard deviation is used, okay, in comparison to the other measures of dispersion, and that becomes one of the advantages for the same, right? So all these are what the advantages of a standard deviation. Now we shall see the disadvantages, right? See the first one, what they've given. The computation of standard deviation is more complicated as comparison to the computation of say the other measures of dispersion. Yes, children, we have seen to the different measures of dispersion, and out of them you saw that while computing say your standard deviation, its formula is much more complicated, right? We have seen that different tactics are to be used, okay, say in the shortcut method also. We have seen that how when in the discrete series or when the group data is being given, how different formulas are to be used to find out the standard deviation, and that becomes one of the disadvantages, right? See to the second disadvantage, the extreme observations say get undue importance in the value of this measure. Yes, children, to find out the standard deviation, as we have seen that all the observations are used, right? And as all the observations are used, you will find that the undue importance has been given, okay, to the extreme observations also, right? And that's why it becomes one of the disadvantages, right? And the last disadvantage for standard deviation is that it cannot be obtained if the frequency distribution have open-ended classes, right? Yes, children, as you know that when the classes are open-ended, we are unable to find out the mean, right? And as we are unable to find out the mean, you can't find out the standard deviation, right? So when the classes have been given and when you are having the open-ended classes, we are unable to find out say the standard deviation, and that becomes its disadvantage, right? So children, over here we just finish up with the topic of standard deviation, right? In the next video, right, we are going to find out, we are going to see, okay, what do we mean by combined standard deviation, right? So for now we are just ending our session here, right? God bless you all.